Okay, once again, welcome all of you for the short session. And I'm doing this one for a special reason, right? Let's get to the work very quickly. If you do have any doubts, please feel free to talk to me and get your doubts cleared, right? Number one, a purpose of teaching you this one is, all of you will not be having the devices now with you to practice the things. And certain basic types of circuits you can try on your own without using real physical components. So that is another reason why I'm teaching you this one. So once after this session, you can start practicing the circuits that we try in the class. Most of the projects that we do in the class, you can do it using the technique that I'm going to show you now. Uh, uh, the fact that is you should understand not all the components are available in the um, version that I'm going to show you, right? Okay. So this software or this platform is known as the Tinkercad. You would have heard about this software, Tinkercad, which is from Autodesk. Autodesk is the one which has this AutoCAD, Maya, 3ds Max, Revit software. All these kind of software are by that particular what do you call company or from that vendor. From the same vendor, we get this Autodesk Tinkercad as well, right? So after my session finishes, you can have a proper account created for Tinkercad. After that, you can start tinkering the work, right? So we go here. So you go to Tinkercad. This is the website. So you just go there to the website, and when you come to the website first time, you should create an account by signing up. It's very easy as usual. Go give a proper email address, then you will get the verification code. With that one, you can verify the email and get the account created. Simple as that. Right. Okay, now let's get started. I already have created my account to save the time. So I'm going to log into my account. I have been using this one for quite some time now. In my account, you're going to see some projects available. When you create your account, it will be having a blank interface. You can either create an educator's account or you can create a account for a student. Either way, you can create the account. Features are not different, but they are customized. That's what I should say. So I am going to use the personal account because I have my email account already signed in. So I'm going to use that username and password. So I am logging into my account. Right. So my interface looks like this. Okay. So basically with Tinkercad, you can create three types of things. One is 3D designs you can create. Straight away, you can send it to a 3D printer and you can get the printouts. Electronic projects, which means electronic circuits you can make, and you can practice coding as well. Visual coding also you can do, drag and dropping that you can do. For our purpose, we are doing it for electronic small circuits, right? Okay. My purpose is to not to teach you the entire thing, but to show you the interface, how to use it, and you can build a small circuit, right? Okay. I'm going to build that blinking circuit today, one off, one on today, and we will be building that on today. After that, I have a challenge for you, all of you. All of you build the Night Rider circuit online and share the link with me so I can check your projects whether that is correct or not. All right. So there are other things like, for example, let's say one student wants to build something and you want your friend to work on it. So it's very easy. You can collaborate with another person's project and you can tinker another person's project. It's very interesting to do and it's quite fun also. All right. So let's get started with this one. So I'm going to click on designs. I will go to designs. And these are my previously done. I have something 30 plus designs, no problem. So I will be clicking not on 3D designs or code blocks. I am going to click on circuits. So once I do that, once I go there, my previously done projects, you can see here, right? So you can see that one. I am screencasting and doing that is could be the reason why it is loading or taking some time to load. So I'm not going to open an existing one. I'm going to do a new one. So I will be clicking on new. You also can do the same thing. That's the option which is called Tinker. Once you come here, go to the circuits option, select new. Okay. So what it asks is whether you want a 3D design, circuit, or a code blocks. I want a circuit, right? So let's click on that, and we will get a blank interface for us to work now, right? So now this is the work area that we get. Feel free to speak, students. If you want to clear any doubts, you can speak that, no problem. You can register your voice as well. After this session finishes, I will be uploading this in my channel, so your voice will be also there. So it becomes a part of a memory, right? Okay. Now, you should understand to your right-hand side, there are some components given. I will be introducing them to you now shortly. In my physical classes, IoT classes, I will be again introducing you the upcoming components as well. Here, these are virtual ones, or not tangible ones. And recently to the collection, they have added a microbit. Microbit is also a open source board where you can do some projects, something similar to Arduino. I'm not quite sure whether it is powerful like Arduino or not, but you can do some interesting things with microbit as well. Excuse me. Right. So first of all, let's take a look at the interface right-hand side. There are three versions or three visuals you can, three view modes you have. One is basic, right? The other one is all. If I put it to all, so this section will be a little bit different, and I can keep on scrolling and I get plenty of components like this. I can use them, right? So here you have a lot of ICs and all, logics, right? Logic gates, ICs are there, you can use them, right? Okay. Right, then let me go up here, and let me again put it to basic. If I want, I can put once again, right? So let's put all. Sorry, I'll put it to basic, and I can search from here also. There is a search bar. For example, if you are looking for an Arduino, Arduino is here, right? Fourth row, third column, you have the Arduino. So if I type ARD, and it quickly comes the Arduino, right? So you can choose which one you want, right? Arduino Uno, right? So you can choose that. So this is the Arduino that you get. For example, if you're hoping to build a project, you can click and drag to the screen. There you go. You get the Arduino done. Another advantage is there.
Excuse me, sir.
Yes, Buddha, go ahead.
Sorry for interrupting, but should we use the sign up option or the join class option where you'll give us a code?
In order to do it in the Tinkercad.
Yes.
You're talking about the Tinkercad. Tinkercad, Buddha, you can get an account created, whatever the account that you want. You don't have to create a class unless if you are an educator, you can create a class and you can put the students just like I'm doing. But for
Yeah,
your
I thought like you wanted us to join or like create an account.
not now. Soon after my session finishes, you can do it, Buddha. My session is not going to be very lengthy. I'm going to do just one project and I'm going to conclude the session. So
Okay.
in between, if the session gets disconnected, you just join in once again. Maybe another 25 minutes, 20 minutes, game finished. After that, you can practice, Buddha.
Thanks.
And once you practice that, further doubts you can ask in the class. I will help you to understand. Okay. Cool. So you should understand here, I have added a component here. When you're doing your assignment work, you can make use of this one to draw the like circuits and all. You can nicely draw this like this. I'm just playing around here, right? So that's possible for you to do. And once you have finished drawing the circuit diagram, you can take a screenshot and put it in the assignment. That's also possible. You can use your wheel in your mouse to zoom in, zoom out like that, right? Because if you are building a complex diagram and you want to put multiple components, you can move here and there. It's a nice swift environment, very smoothly working, right? Okay. You don't need a huge RAM to do this one, so it works quite fine. Though I have 16 GB RAM, you don't need a huge amount of RAM to work on this, right? Okay. Okay, let me keep it like that. And I hope you can see the main things that we studied: pin numbers and reset buttons, USB ports, a power button that regulate IC, the what do you call this, programmable ROM, what do you call Arduino, sorry, analog pins, digital pins, power pin, all these kind of things. You can see them, right? Okay, so that's our Arduino. Then I'll delete this one and our other components will be back, right? Other components are back, right? So let's say you want to work with a breadboard. You can drag and drop a breadboard here. Right? The small one is available, big one is not available. Breadboard is really nice. So if you move the mouse pointer over any rail like this, you can see that is nicely getting selected. That side it is getting selected. So which means this way it is connected. And if I bring it here, you can see that is also nicely getting connected. All right. Okay. So this is basically a breadboard. You can wire these things up. I'm going to do that one and show you in a second, right? All right. Next one, I'm going to show you how to put an LED as well, right? And how to put a resistor as well, right? Okay. Now what we will do is we will keep the breadboard aside like this, and let's put a LED directly like this, right? Just drag and drop. And once you select components from here, you can change the name, change parameters. You can change from here. When you choose an LED, you can change the name of the LED as well as you can change the color. For example, there are some limited colors like, for example, you can go to orange, green as well as yellow, right? So they are not very bright like things, but I like to keep it into red, so which is more visible. All right. If you think that it's too tiny, like just zoom in a little bit like that and start working with that. Right. Okay. So let me bring the mouse pointer here. You can see that says anode, and this says that's the cathode. Okay. Right. Step 1, do the wiring. Step 2, do the coding. Right. As I'm teaching you, I am not showing you all the components. My task is not to show you the whole interface to you. I am building a sample project with you, and at the same time, I'm introducing the platform and features in it. That's it. Okay. What we will do is let's do the wiring. Okay, you can make use of this area as well. This shows the wire types and this shows the wire color, right? For the powering up, so I'm going to connect pin 7 to this one, right? Pin 7 here. So I'm going to choose color red, right? I'm clicking on pin 7 and I bring my mouse pointer, and once I hit the anode section, you can see it connects like that. Can you see that? Right. Then I will click once more. Wiring is done. Now, if I move the LED, wire will nicely come like that. And let's say you move it here and you want to break like this, you just double click, move it, double click, and move it, and take it like this. So you can beautifully do that, right? So that's pretty simple. So if you select a point like this and press the backspace, that point will be deleted. Very simple, right? So let's keep it very simple like that. And the ground pin is here. So I'm going to click on ground, and I like to use black color for that, right? Let's choose black and click on ground and click into the cathode section, right? Now, if you want to simulate this, you can see the USB cable is unplugged here and the LED is not glowing here. In this one, LED is not glowing, so which means it's not powered up, there is a way you can run this one. There is an option called start simulation. And if I do the start simulation, there's nothing going to happen because I haven't written any code in. Wiring part is done. Coding I have to do, then I have to test this. All right. You should understand, I told you each pin, digital pin outputs a 5 volt, 1 ampere, which is way too much for the LED. LED will be burnt. Okay. So now anyways, even the LED burns, no problem because it's a virtual one. So we're going to try this anyway and see what will happen. Okay. Right. So next step 2, we're going to do the coding, then I can do the simulation. Right. Let's open the code window here. If you open the code window, you will see a small code like this. You can make it a little bit bigger. I'm afraid I can make this one bigger than this. I can make it from here big, but I can't zoom into this one. This is visual coding. You just drag and drop the things and you can do the code. Accordingly, the code will be generated. So I'm not a big fan of this one. I'm not going to do this one. You need to study how to do this one. I'm actually not a very fan of this one. Okay. Yeah, I think it is Scratch, Zaid. You can try that one. Anyways, I like to do the code in a hard code way. I like you people doing, right? So what I do is I don't care about this. What I will do is I will open the option here, blocks, and there's an option called blocks plus text, and there's an option called text. I love to go for the text option. There is one limitation. If you go to the text, you cannot go back to the block view again. So you have to do it carefully, right? So I'm going to say continue. I don't want to go to block view. Right, that the code is there for me. I'm going to delete my code for you and delete the code for me. Right, and I can increase the font. I like to put large fonts, right? So, right, I hope you can manage that font size, right? So C++ code, it says, right? Okay, let's do that day code, right? I hope you remember the code, right? So let's do a code here. First code, pin mode, isn't it? Pin mode, pin number 7, comma, what should I put? Input, output. Feel free to speak, guys. Right, output. Okay, Dhanuksha is speaking. I can't hear you anyways, right? Loop. So we're going to say digital, sorry, digital right, digital right. Then we say pin number 7, comma, high. So that will turn on the LED, and I will say delay 1000 milliseconds, which means it's 1 second. Again, digital, then we'll say, so digital right, we'll say 7th pin,
Low.
okay, and we'll put, say your mic is turned on to the right, okay, and low, we'll put like that, and delay 1000, like this, okay, right, you were saying the answer, correct. So the project is ready, we can test this one, right? So if you want, you can send the code inside, like that, no problem. You can test it like that. So once you click on that, code will come like this, and you can click on it, code will disappear, right? Okay, let's keep like that, and let's click on the simulation option and see. You will see there will be a warning coming. The LED's lifespan will be less. So, okay, now you can see every second LED is glowing, and there is exclamation mark is coming, and it says current through. It says current through LED is 47.0, it says it's milliamperes. So while recommended maximum is 20.0 milliamperes. I told you that day. So the problem is we are giving way too much of current for this, and it's going to damage this one. If it is a physical component, it will definitely damage. Here it's not going to work, right? All right, let's stop the simulation. Let's detach this one. Press the delete backspace. Press the I just deleted the power line. That's it. Now I'm going to click on a resistor now. Let's create a resistor here, right? Let's go closer to that. And you can see the color codes also available here. Later, I'll teach you how to read the color codes and how to get the values according to the colors, how to read the values. And you can see, you should understand resistance is measured in the value ohms. The person who invented that law also, Ohm's law. Takshi is here. Yes. So, and you can put the resistor in between this. So I'm going to first of all change the resistance here. It says 1 kilo ohm. That is not necessary. I'm going to type here 220 ohms, 220 kilo ohms it says. So color automatically changes. I'm going to check that to ohms, horseshoe mark. So right, red, brown is the color code for 220 ohms, 220 ohms resistor. Now again we click on 7 and we join here, and we click on anode, we click here. So in between the LED and the Arduino, we have put the 220 ohms resistor. Now let's run the project and see. Coding you don't need to change, everything is same, only we change the wiring a little bit, added a component, that's it. So let's run the simulation and see how it works. There we go. No warning message coming, and every second nicely it is glowing and it is disappearing. Okay, right. Okay, let's pause the recording and let's take a quick feedback from you.
Thank you, sir. Good night.
Thank you, sir.